And you should remember this concept, because here this n equally spaced frequency samples of DTFT are known as DFT, right? So that is why I have introduced this slide. So this DFT is obtained by performing the sampling operation in both time and frequency domains, whereas in DTFT, sampling operation is performed only in time domain. Here it is both in time and frequency. In DTFT, only in time domain. And DFT is a discrete frequency spectrum. And DTFT is a continuous function of omega frequency, continuous function. And next is fast Fourier transform. And here FFT. It is proposed by Cooley and Tukey in 1965. It's a highly efficient procedure for computing the DFT of a finite series. Why we are going for FFT? Here, look at this equation. In this equation, if we want to calculate for n is equal to 8, then the summation over ranging from 0 to 7, n minus 1. So n is equal to 8 in the sense n minus 1. So n is equal to 0 to 7, x of n into e power minus j 2 pi k n divided by 8. My equation will be like this. So if I want to calculate x of 0, so if n is equal to 8 in the sense, I will have my equation as it will start from 0. So 0 to 7. So x of k value is 0 to 7, and small values also ranging from 0 to 7 here, n minus 1 in general. So I want to calculate first value, x of 0. Capital X of 0, k is equal to 0. So in that case, I have to substitute my k values equal to 0 in this equation, and x of n. X of n in the sense, here the summation over small n ranging from 0 to n minus 1. So I have to expand my equation like this. X of 0 e power minus j 2 pi n. 2 pi n is here now 0. 0 into k is equal to 0 in this case. So 0 into 0 divided by 8 plus x of 1 into e power minus j 2 pi k is 0, n is 1 divided by 8 plus x of 2. Likewise, we will expand our equation till x of 7. And then you have to calculate individually. And finally, you have to add everything to get your x of 0 sample. Right? In our Fourier transformed, discrete Fourier transformed signal, the first sample x of 0, k is equal to 0 position. The sample is obtained now. And similarly, we have to do for k is equal to 1, k is equal to 2, k is equal to 3, k is equal to 4, till k is equal to 7. Right? So this is a time consuming process. If n is equal to 8, then again we can able to manage some way. But if your n value is larger value, n is equal to 255, 250, 256, or n is equal to 1026, likewise very big number, then we cannot able to do it. It is a very time consuming process. Because of that, we are going for FFT.